All right, so I'm going to do a example here with two dependent samples or a matched pair example. So researchers collected data on the numbers of hospital admissions resulting from motor vehicle crashes, and the results are given below for Fridays on the 6th of a month and Fridays on the following 13th of the same month. Use a 0.05 significance level to test the claim that when the 13th day of a month falls on a Friday, the numbers of hospital admissions from the motor vehicle crashes are not affected. All right. So they're comparing the Friday the 13th to the previous Friday. Trying to use that previous Friday because, you wouldn't want to compare the Friday the 13th crashes in December, let's say, to a non-Friday the 13th in August, right? Because winter weather and stuff more likely to have crashes. So that's why they're trying to link it to the Friday before the same month. So let's get that off there. There we go. So anyhow, so there it is. So not affected. In other words, they should be equal. So by the way, mu sub d, we're looking at the difference between these two values. So yeah, the mean of the differences. Okay, and we think they're not affected. In other words, we think they're equal, and the alternative is not equals then. Okay, we're not saying they didn't say they think there's more crashes on Friday the 13th, though. That's probably what you might think if you're superstitious or something. But that's not what they're claiming. They just say that they're not affected. So in other words, the same. All right. There we go. Well done. Okay, so now let's run through all the stat stuff. We're going to just really, we're just going to let StatCrunch handle this whole thing. We're not going to really write a whole lot out. Again, if you see that icon there, that means you can open the data right in StatCrunch, and then you don't have to retype it. So this is a hard one. If you look on the formula sheet, by the way, we are multiple means. This is paired. It's dependent. So we're in this first column. There's all our formulas. These formulas are kind of nasty and all that. Just because the S sub d, the standard deviation of the differences, is a little bit nasty and all that. But down in the bottom, StatCrunch, that's where you go. However, it's a little bit harder than that. There's a couple little things you need to click and do, so let's demonstrate that. And again, we'll just kind of let StatCrunch do all the work. So we are going to go to T-stats, because again, if you look on the formula sheet, this is a T distribution, so it is a T-stat. So we'll go back. Stat, T-stats, we're paired. So column 1, Friday the 16th, column 2, Friday the 13th. Always click Save Your Differences. And we are doing a hypothesis test, and the difference is 0, as in there's no effect, so 0 difference on average, and not equals, we already had that. So we're good there. So we're going to hit Compute, and it runs it all for us. So there's our T-stat and our p-value. All right, now be careful. This 1.108, that is not the S sub d. That's your standard error. Again, you look on the formula sheet. Standard error is this part over here on the right. S sub d is the part on the left. So to get your standard deviation of the differences, which is not standard error, although it doesn't ask for it in this problem, I want to show how to do it. We click Save Differences, and here's why I wanted to do that, because now the differences are in that column, and now I want to know what is the standard deviation of those differences. Well, we're going to go to Summary Stats, Columns, select the Differences column, and select Standard Deviation. Hit Compute, And now I have the standard deviation of those differences. In other words, S sub D. So that's how you find S sub D. All right. And notice how S sub D is not the same as the standard error down below. They're different. Okay. Again, going to the formula, you actually use S sub D to calculate the standard error. All right, I got everything I need except one last piece, and that is the critical values. I always like to have the critical values to get an idea where the rejection region is. All right, and we are using the t-distribution, and so we critical values come from the calculator, t-distribution. Last but not least here. Now, what are the degrees of freedom? If you look on the formula sheet, it's the number of pairs minus 1. There are 6 pairs there, so the degrees of freedom is 5. Now, be careful. The alternative is not equal to 0. So this is a two-tailed hypothesis test. So that means I need to split my alpha in half. So instead of 0.05 on one side, I have to split it. Half of 0.05 is 0.025. So I'll have 0.025 on each half, or in other words, alpha over 2. And there we go. So those are my critical values, and it's symmetric. So if it's minus 2.57, the t-distribution is symmetric. Then it'd be a plus 2.57 for the right-hand side. So I don't need to look up both. I can just get one, and through symmetry, I know the other. So I got everything I need here. I got my p-value as well. If the p is low, the null has got to go, and the p is low, so we know we're going to reject. Also, where's my critical value? Negative 2.57. Where's my test statistic? Negative 2.8. So that negative 2.8 is going to push me past that critical value and out into the rejection region. So it's all links together. It all says the same thing. All right, so I'll leave this window on the side here. I'm going to jump over to StatCrunch, and we'll just throw all our values in now. So test statistic, round to 3 decimal places, so negative 2.858 if I round. Good job. It did ask for my critical values, and again, there's 2 of them. It's two-tailed because of the not equals in the alternative hypothesis. And we can see from StatCrunch, the calculator, critical values 3 decimal places, so 571. And you don't need to put minus in there or plus. It's already got the plus and minus in front of the box because, again, a left hand and a right hand tail, 2 tails. Oops, I forgot my decimal place. There we go. Well done. Well, thank you. And continue. And we already said that the p is lower than alpha, so if the p is low, the null's got to go. So we are going to reject the null, and the null said there is not an effect, was what we were checking up above. And so we're rejecting that idea. So in other words, we think there is an effect. So there is sufficient evidence to warrant rejection of the claim of no effect. So we're either in B or D. Look at the end. Hospital admissions appear to be affected. Yes, there it is. So there it is. That's how you run through a matched pair or dependent problem in StatCrunch. Just a lot of little things to click here and there that make it a little more challenging than most of the other problems. But with the end of this video, I hope that helps out and makes it easier for you.